In this video, we're going to work through some problems using power series. We're going to essentially start with a known power series and derive a different power series from this, so sort of power series operations. So the first question here, we're going to use the equation 1 over 1 minus x equals the sum from n equals 0 to infinity x to the n. So it's just a given power series. We're going to assume that's true. We're going to use that to find a power series for 1 over 1 plus x. So let's write down what we've got. What we had is we knew 1 over 1 minus x is the sum n equals 0 to infinity x to the n. Okay, and what we're trying to find is 1 over 1 plus x. So the goal here is to sort of write 1 over 1 plus x like 1 over 1 minus something. Well, if you think about it, this is 1 over 1 minus negative x. Then what we can do is we can put negative x in for x in this original sort of series. So we get a sum n equals 0 to infinity, and it will be negative x to the n instead of x to the n. So nice little simple thing here. And then this would be sum n equals 0 to infinity. You can split negative x into negative 1 times x, so you get negative 1 to the n, x to the n. So there's a series for 1 over 1 plus x. All right, next question. Here we're going to use the equation 1 over 1 minus x equals summation n equals 0 to infinity x to the n. Same equation. Now we're going to find a power series for 2 over 2 minus x. So we're going to do 2 over 2 minus x. We can scroll back up. We're going to use this same original series. 1 over 1 minus x is the sum n equals 0 to infinity x to the n. So I'm going to take 2 over 2 minus x, write that as 1 over 1 minus something. That's my goal. So I've got this 2 in the denominator. I need to get rid of that. So what I'm going to do is divide the top and bottom by 2. So I'm going to get 2 really divided by 2 over 2 minus x over 2. So 2 divided by 2 is 1. 2 minus x is 2 over 2. That's 1 minus x over 2. Well, that's fortunate here because what we get is 1 over 1 minus something. That something is x over 2. So this should be a sum n equals 0 to infinity. Would be x to the n, but instead of x, we have an x over 2 to the n. And you might rewrite this as a sum n equals 0 to infinity, x to the n over 2 to the n. Next one. So we've got here, we want to use the equation 1 over 1 minus x equals summation n equals 0 to infinity, x to the n, to find a power series for 1 over 4 plus x squared. So same summation. Let's just write that up again. Summation n equals 0 to infinity, x to the n. This is 1 over 1 minus x. And what we had is 1 over 4 plus x squared. So 1 over 4 plus x squared, I'm going to write as 1 over 1 minus something here. So I need to get rid of this 4, so I'm going to divide top and bottom by 4. It's 1/4 over 4 plus x squared over 4. Now this 1/4 on top, I'm just going to have to factor out as a constant in front. That's okay. 4 over 4 is 1 plus x squared over 4. Okay. And then what we'll get is 1/4 times 1 over, and this will be 1 minus x squared over 4. And so now we can use our formula where we do 1 over 1 minus x squared to the 4th. Let's do 1/4 times this 1 over 1 minus x squared to the 4th is going to be sum n equals 0 to infinity. And it's just the x squared over 4 to the n. And then I could sort of split up this x squared over 4 and write it as summation n equals 0 to infinity x to the 2n over 4 to the n. You could write 4 to the n as 2 to the 2n if you wanted to. I could also, I've got a 4 on the outside. I don't know, there's various things you could do here. What I've got there is probably a fine answer. But I could move this 1/4 to the inside and write this as x to the 2n over 4 to the n plus 1. I could write that 4 to the n plus 1 as a 2 to the n plus 2. Sorry, 2 to the 2n plus 2. Right, but in any case, I get something like one of these series here. So idea here is we're taking, sort of somewhat different series and pretty easy substitutions here, really, and just use known formulas. Next one. This one's a little different. We're going to start with the same basic formula, but now we have x squared over 1 minus x. So we have x squared over 1 minus x. Now, what I'm going to do is I'm going to look at this one as x squared times 1 over 1 minus x here. And then my 1 over 1 minus x, that's the series we've been using, that's summation n equals 0 to infinity x to the n. And now I can bring the x squared inside my series, n equals 0 to infinity. This will give me an x to the n plus 2. And that works out as sort of an acceptable answer here. So x squared over 1 minus x is x squared times 1 over 1 over x squared times 1 over 1 minus x. And you get this summation n equals 0 to infinity x to the n plus 2. But find a power series for 1 over 1 minus x squared. So you've got that 1 over 1 minus x squared there. It says a hint, find the derivative of 1 over 1 minus x. So what we're going to do is we're going to say 1 over 1 minus x squared is what we want. And the hint was really 1 over 1 minus x. Let's find a derivative of this and see what we get. So that equals, let's see, well, that's 1 minus x to the negative 1. So that's negative 1 minus x to the negative 2. And then we take a derivative of the inside is a negative 1. What you get is 1 over 1 minus x squared. That's exactly the sort of function we're trying to find a power series for. And so 1 over 1 minus x squared, this is a derivative with respect to x, 1 over 1 minus x. Well, now we can plop in our series for 1 over 1 minus x. That's x to the n. And then there's a rule here where as long as I'm sort of within the right radius of convergence here, right values of x, I'm going to kind of ignore that for now. I can pull my derivative inside. Here. And so what I get is a summation n equals 0 to infinity, just n times x to the n minus 1. And then what I would look at here is that if n is 0, 0 times x to the n minus 1, x to the negative 1 is actually a 0, so I'm going to get rid of the n equals 0 term here. So I can just drop out the n equals 0 term because it's 0, so this is n equals 1 to infinity, n times x to the n minus 1. Now, if you wanted to, you could convert this. Here I could make my x to the n minus 1. I could increase the n's inside, n plus 1 x to the n, and then decrease on the outside here. So this would be an alternate form here where I sort of did a substitution where we replaced n with n plus 1 in this second one. All right, next one. Find a power series for x over 1 minus x squared. So x over 1 minus x squared, well, that's x times 1 over 1 minus x squared, which is x times the problem we just did. So the previous one, we had 1 over 1 minus x squared. We had a sum n equals 1 to infinity, n times x to the n minus 1. So we get times summation n equals 1 to infinity, n times x to the n minus 1. And then I can just bring this x inside my summation, n equals 1 to infinity n. X times x to the n minus 1 is just x to the n. So you get a nice quick series for x over 1 minus x squared. All right, 7. We're going to do a power series for 1 over 1 plus x squared. So what I'm going to do is I'm going to notice this as 1 over 1 minus negative x squared. So it looks like my 1 over 1 minus x form. And then using that formula, I get n equals 0 to infinity. This is just negative x squared to the n. And then you can kind of manipulate this. You can pull out the negative 1 to the n. X squared to the n is x to the 2n. So we get 1 over 1 plus x squared is n equals 0 to infinity, negative 1 to the n, x to the 2n. Fairly short and sweet. Next one, use your answer to the previous question to find a power series for inverse tangent x, or arctangent x. And what we're going to do here is we're going to consider the antiderivative of 1 over 1 plus x squared. So I'd like to be able to represent arctan x as a series here. So let's just sit here and I've got tan inverse x here. Well, this is going to be the antiderivative of 1 over 1 plus x squared dx. So the idea is that if you integrate 1 over 1 plus x squared, you should end up with arctangent of x. Or if you differentiate arctangent x, you get 1 over 1 plus x squared. But I want this antiderivative one because I already have a series for 1 over 1 plus x squared that I've got written up here already in my box. So I get an antiderivative, sum n equals 0 to infinity, negative 1 to the n, x to the 2n dx. And then sort of rules of, if I have convergence here, I can bring my integral inside of my series given sort of the right x values and right intervals of or radius of convergence, I guess intervals of convergence. I'm not going to worry about that here. I'm just going to assume it works and for now. So I'm going to do an antiderivative of x to the 2n. So I get sum n equals 0 to infinity. Note negative 1 to the n doesn't have an x in it. X to the 2n, I get an x to the 2n plus 1 over 2n plus 1. Okay, and you really probably should have a plus c here as we work this out. So we'll just think about that in a bit here. So you do sort of these, add up all these constants. You could think of them as just 1 plus c here. So what we're going to get here, this would be our answer, but I want to make sure that constant works out. So what I'm going to do here is I'm going to think about arctangent of 0. So that should be something whose, it's going to be 0. So what I want to do is if I plug in a 0 for x, I want to get 0. Well, if you plug in 0 for x, n equals 0, that's going to give me x to the first here. So every term inside of my series is 0. That means the c has to be 0 to make this 0 work out. If this was like a half here, you make the c equal to a half. So our answer here, it's kind of ugly, is that inverse tangent x is summation n equals 0 to infinity. We get a negative 1 to the n, x to the 2n plus 1 over 2n plus 1. So all we had to do was take our original series and integrate to get an antiderivative, or sorry, get a series for arctangent x. Next one. Here we just want to find the first 3 terms of a power series for 1 over 1 minus 2x times 1 plus x squared. And we've got a bit of a hint here where you can split this up into 2 series that we should be able to deal with. Whoops. Sorry. Let's get rid of that. And we need a new page. So what we've got is 1 over, what was it? 1 minus 2x times 1 over, I believe it was 1 plus x squared. Yes. Okay, so what I'm going to do now is convert these to series. So this is summation n equals 0 to infinity 2x to the n times, let's maybe put that in parentheses, summation n equals 0 to infinity negative x squared to the n. And maybe I could rewrite this as n equals 0 to infinity 2 to the n x to the n times summation n equals 0 to infinity negative 1 to the n, and we'll get an x to the 2n. Okay, and what we want here, we go back, is the first 3 terms, presumably first 3 non-zero terms. And so what I'm going to do is just write out the first few terms of each of these. So if I do n equals 0, that's going to be 1 here. N equals 1 will be plus 2x plus 4x squared plus 8x cubed plus 16x to the 4th. That's more than 3 terms here, but gives us a sense here. And then this second series, when n is 0, I'll get 1. Then when n is 1, I'll get a negative, and it'll be minus x squared plus x to the 4th minus x to the 6th plus x to the 8th, and so on. Here. So the first 3 terms, what I'm going to do is look for a constant term. How do I get a constant? Well, I can take a constant from the left, that's my 1, times a constant from the right, that's my 1. So this is 1. And then if I want to get a x term, well, I could do a 1 times an x, but there's no x on the right sort of second factor. So I'm going to have to do a 2x times a 1. And then if I want to get an x squared, how could I do that? I could do a 1 times a negative x squared here. Or I could do a 2x. Well, there's no x on the right to make that x squared, but there is a 4x squared and a 1. So I can do plus 4x squared, and then plus blah, blah, blah. That's already my first 3 terms here. And so what I get is 1 plus 2x plus 3x squared plus some more stuff here. So in some sense, really, I have asked for the first 3 terms. That's the 1 plus 2x plus 3x squared. Next one. Next 2 problems, we're actually going to find the first 4 terms of a power series. Again, probably the first 4 non-zero terms of a power series for cosine squared x in 2 different ways. First, I'm going to start with a known series for cosine x, and I'm just going to square that. So I'm going to multiply it by itself using essentially the same process we just did. So let's take a look at that. So our formula for cosine x, or our series formula, turns out to be n equals 0 to infinity, negative 1 to the n, x to the 2n, over 2n factorial. And this is the kind of thing you would just sort of look up or use sort of derivatives and find a Taylor series, or maybe you call it Maclaurin series here for this. But we're going to assume this is known here. So then what that means is that cosine squared x should be cosine x times cosine x, which is n equals 0 to infinity, negative 1 to the n, x to the 2n, over 2n factorial, times summation n equals 0 to infinity, negative 1 to the n, x to the 2n, over 2n factorial. So I'm just going to expand these out. So if I plug in n equals 1, I'm going to get 1. Sorry, n equals 0 gives me 1. N equals 1, I'm going to get a negative x squared over 2 factorial. Plug in x equals, or sorry, n equals 2. I'll get a plus x to the 4th over 4 factorial, and then an n equals 3. Sort of write out enough terms so I sort of have what I need. Second factor is the same thing. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6th over 6 factorial plus some more stuff. And so what I'm going to get here, maybe before I do that, let's just evaluate the factorials so we don't have to write those down. I have 1 minus x squared over 2 factorial is 2. 4 factorial is 24. 1 times 2 times 3 times 4. And 6 factorial is going to be 720. And so then I'll get 1 minus x squared over 2 plus x to the 4th over 24 minus x to the 6th over 720 plus some more stuff. Okay, and then what we wanted, how many terms do we want? 4 terms. So let's think about, can I get a constant term? Well, that's going to have to be a 1 times a 1. So that's a 1. What about an x squared? Well, I could do 1 times negative x squared over 2. Or negative x squared over 2 times 1. So it'll give me an x squared. That's 2 terms. Now you could argue there's a 0x there. I'm going to look for 4 non-zero terms here. Let's see. I've only got even powers of x, so the next one I could possibly get is x to the 4th. It's going to be 1 times x to the 24th. So that's x to the 4th over 24. Negative x squared over 2 times negative x squared over 2 gives me an x to the 4th over 4. And then x to the 4th over 24 times 1 gives me an x to the 4th over 24. So that's 3. And then x to the 6th, I'm going to get 1 times 1 over 720. And then negative 1/2 times 24. X squared times x to the 4th is x to the 6th. So this will be minus x to the 6th over 48. And let's see, then I could do x to the 4th times x squared. That'll be minus another x squared over 48. And then minus another, sorry, x to the 6th over 48 minus x to the 6th over 720. And then there's some more terms, but this should be the first 4. So what I end up with is 1 minus a half plus a half is 1. Let's see, this is 6 24ths, 7 24ths, 8 24ths. It looks like a third x to the 4th. Minus, let's see, 48 times 15 should give you 720. So minus 15 minus 16 7/20ths, and there's 2, so that should be minus 32 7/20ths. But we can, let's see, divide out by a 4 would give you 8 over 180. Divide out by another 4 gives me 2 over 45. So if I'm doing this right, it should be negative. I believe that's 2 over 45 x to the 6th. Let's maybe check that with a calculator. I don't really trust my sort of my arithmetic necessarily. Here, so what we've got is 1 divided by 720. Whoops. Plus 1 over 48. Take that, and then we've got that times 2. And then I'm going to go to a fraction. Maybe I should trust my arithmetic here. Okay. Begin with 1 minus x squared plus 1/3 x to the 4th minus 2/45 x to the 6th plus blah, blah, blah. So that's really the first 4 terms of cosine squared x. Last one, we're going to do cosine squared x, find the first 4 terms again, but now we're going to use a different trig identity, a different setup. So we're going to use here, we should get the same answer, we can check that. But now I'm going to use cosine squared x is 1 plus cosine 2x over 2. Note this is 1/2 plus 1/2 times cosine 2x. So what you get is this is 1/2 plus 1/2. Cosine x, let me just write that up here again. Cosine x was the sum n equals 0 to infinity, negative 1 to the n, x to the 2n over 2n factorial. So what I'm going to do here is I'm going to plug in n equals 0. See, n equals 0, that's going to give us 1. n equals 1 is going to be minus. Now I'm plugging in 2x, so it should be a minus. It should be 2x squared over 2 factorial. Plus, next one will be 2x cubed over, no, not cubed. Next power is 4 over 4 factorial. And let's do a minus 2x to the 6th over 6 factorial. Plus some more stuff. So what you get is 1/2 plus 1/2 times 1 minus, see, this will be 4x squared over 2. 2 factorial is 2. 2 to the 4th is 16, x to the 4th, 4 factorial is 20. So I get 16x to the 4th over 24, 4 factorial is 24, minus, see, we get 2 to the 6th is 64, x to the 6th over 6 factorial is 720, plus some stuff. So I'm going to get, let's see, a half, plus a half times 1 is a half. 4 over 2 is 2, but I'm going to get a minus x squared. All right, multiply by the half. 16 over 24, that's 2/3 times a half is 1/3. And then 64 over 72, let's see, you get 30 divided by 2 is 32 over 720. And that was, if I go back, 32 over 720 divided by 720. I think that's the same thing we had before. Yeah, 2/45. So what we should get is minus 2/45 x to the 6th plus blah, blah, blah. Now this should match what we had before, does it? Oh, sorry. Should be close. Not what I have to do now is 1/2 plus 1/2 is 1 minus x squared plus 1/3 x to the 4th minus 2/45 x to the 6th. So I had to do the 1/2 plus 1/2. Now let's just check here. Let's get rid of that box there. Let's check here. Does that match what we had before? We had 1 minus x squared plus 1/3 x to the 4th minus 2/45 x to the 6th. So it does work out the same. So we got 2 ways to find cosine squared x, and that's generally the case here. There's multiple approaches to a lot of these questions. And that ends our solutions.